Welcome back to Mr. Hassan's Maths channel. I'm answering a question now from one of the Solomon papers. This is Solomon F from the C3, which is now the P3 collection, this is question number 4 from the Solomon F paper. And it's question 12 from my Differentiation 1 worksheet of my P3 worksheets. And this question was requested by one of the students for me to answer. So it's a curve has equation x equals y times the square root of 1 minus 2y. Show that dy dx is equal to the square root of 1 minus 2y over 1 minus 3y. So here we see that we have to find dy dx. But what we notice is the answer is not in terms of x, it's in terms of y. It's in terms of y. And so here we have to do something slightly different than normal. We have to differentiate this expression in terms of y. So we have to find the x dy first. And all of our expressions will be in terms of y. And then we just write down the reciprocal. It's kind of like a kind of branch of the chain rule. So once we found the x dy, we can write its reciprocal, and that will hopefully give us this. So it's finding dy dx in terms of y, not in terms of x. Okay, that's what they're asking us to do. So the first thing we do is we see that if we want to find the x dy, we have a quotient, we have a product of two separate factors. We have x equals y times, and we can write this as 1 minus 2y to the power of a half. So what we're going to do is we're going to say let u be y and let v be 1 minus 2y to the power of a half. So now we're going to find du dy. It's not du dx, it's du dy. We're going to differentiate this expression with respect to y. So I'm going to write it like this. Instead of u dash, I'll put du dy to make it clear that we're differentiating this with respect to y. So this becomes 1. I'm not differentiating with respect to x. I'm differentiating with respect to y. Find the x dy. So I split it into your product. This is your u, this is your v. So I'm finding du dy, and then I'm finding the v dy. Alright, so I can write u dash and v dash, but I'm just doing it in this way so that you can see that I'm differentiating with respect to y. So here I'm going to use the chain rule. I'll do a half times the bracket as it is, take 1 from the power, and then multiply by the differential of what's inside the function, which is minus 2. If I differentiate 1 minus 2y with respect to y, I get minus 2. Okay, so that's going to give me basically the minus 2 and the half cancel out. So I'm left with minus 1 over 1 minus 2y to the power of a half, you could say. I'm just writing it in this form like this. So now I'm going to use the product rule. The x dy is equal to, multiply these two together. So I have 1 times 1 minus 2y to the power of a half, plus these two multiply together. So I'll have y times minus 1 over 1 minus 2y to the power of a half. Okay, so I'll end up with 1 minus 2y to the power of a half, plus or minus, you could say, minus, and it's going to be y over 1 minus 2y to the power of a half. Now if I make this into one fraction, okay, I'll have the common denominator of 1 minus 2y to the power of a half, and then I'm going to have to make this into, have to multiply both the top and bottom of this by 1 minus 2y to the power of a half. All right, this is going to be basically 1 minus 2y to the power of a half times itself, which is 1 minus 2y, and this is going to be, as it is, just minus y. It's like you can say this is over 1, this times this, and that times that. That gives you 1 minus 2y, okay, and then minus y over 1 minus 2y to the power of a half. So you have 1 minus 3y over 1 minus 2y, and this is the power of a half means square root of. And that's exactly what we had to show. That, well, not quite yet, okay, just make a bit more space. We're almost there. We've got dx dy. We have to, in the end, find dy dx. So this is, as we know, this is dx dy. So we say dx dy is equal to what we found, which is 1 minus 3y over the square root of 1 minus 2y. And we want to find dy dx, which is the reciprocal of that. So dy dx is the square root of 1 minus 2y over 1 minus 3y. And that's what we had to show. And there's the answer to part A. And then it says part B, says the point A on the curve has y coordinate minus 1. Show that the equation of the tangent to the curve at A can be written in this form. So we have the point A has a y coordinate minus 1 and the x coordinate we have to find, of course. And we need to know the gradient of the tangent of the curve at the point A. So we need to use these equations. So we know that when y equals minus 1, that'll be xa. That's going to be 1 times the square root of minus 1 times the square root of 1 minus 2 times minus 1. So the x coordinate of A will be minus 1 times the square root of 3. So it's going to be minus root 3. Okay, so that's going to be the x coordinate of A. So I'll just replace that here. So that's minus root 3. That's the x coordinate of A. And the gradient of the tangent at A is going to be given by the square root of 1 minus 2 times minus 1 over 1 minus 3 times minus 1. So that gives you the square root of 3 over, and that's 1 plus 4, which is, no, 1 plus 3, which is 4. Okay, 1 plus 3, which is 4. So it's root 3 over 4 is a gradient of the tangent at A. That's root 3 over 4. So therefore we can say y minus y1 equals m times x minus x1. Okay, so we have all the information we need here. Okay, we have everything we need. We have y1, which is minus 1. So you have y minus 1 equals m, which is root 3 over 4 times x minus root 3. Okay, how do they want us to express the answer? As integers. So I'm going to multiply everything by 4. So this gives you y plus 1 equals root 3 over 4 times x plus root 3. So the next step is we're going to multiply both sides by 4 to get rid of this. And we can also expand this bracket. So we have 4 times y and 4 times 1 equals, and this will be root 3 times x and root 3 times 3, root 3, which is 3. And then we can write it in the form that they want. We will keep this as positive. So we'll have root 3x, and this will become minus 4y. And we have 3 minus 4, which is net minus 1, equals 0. So this is the form that we want the answer in. Okay, where it says where p and q are integers to be found. It doesn't mean you have to write them down, but we could write them down. P equals minus 4 and q equals negative 1, just to be clear. But that's fine. If we write it in this form, all right, as long as we have minus 4 here and minus 1 there, that's fine. Okay, written in this form. So there's the answer to question number 4 of the end of topic worksheet. 4 of Solomon F, which is 12 from the end of topic worksheet, differentiation 1 from my P3 collection. And this question, what was maybe slightly different about it was the fact that we have to find dy dx in terms of y. And we can't make y the subject easily, so we got to find the x dy first, and then write that as a reciprocal of itself, and then we got the answer. And then from there, everything else is quite normal, as we have learned previously. So there's the answer to this question. Other questions from this paper can be found in the playlist over here. That's from Solomon F. Other questions from this worksheet can be found in the playlist that you'll find the link for over here. Other questions from differentiation in general in P3 can be found over here, and you can subscribe to my channel by clicking on this link. And let me just fix this typo here. I just noticed. That's better. Okay. Thank you for watching, and see you soon.